So in this session, we will discuss about the probabilities. So we'll see what do you mean by probability, and we will see the what are the elements of probability. Because first, before going into the probability, we have to know what are the elements that are present. So we have to know some simple elements. So with the help of the simple elements, and if you know the simple elements of the probability, then you can able to solve easy problems of the probability. So before getting into the problem solving of the probability, we'll discuss about the elements of probability. So first one we'll discuss sample space and event. So what do you mean by sample space and what is an event? Suppose uh, suppose I am considering one experiment. It means I am conducting one experiment. It means um, during this experiment I don't know the outcome. It means we cannot able to predict the outcome of the experiment. So it is certainty. So while conducting an experiment and the outcome is not predictable with certainty in advance, it means we are not able to predict the certainty in advance. It means we are not able to predict the outcome during an experiment. So and also the outcome of the experiment will not be known. So even we don't know the outcome of the experiment before in advanced mode. So we'll discuss what are the possible outcomes during this experiment. It means it is nothing but suppose I'm taking one real life example. So consider a roll die. So suppose I roll a die. So after rolling a die, we will get some possible outcomes and so we'll get some possible output like so. A dice contains six faces. So when we roll a die, we'll get the um, uh, we'll get some possible outcomes like one, 2, 3, 4, 5, and 6. So those are the possible outcomes of the event. So these are the set of all possible outcomes. It means even we don't know the predicted output of the experiment, at least we are able to perform some experiment and we're able to get some set of all possible outcomes. So here set of all possible outcomes is called as is known as the sample space. So what do you mean by sample space means the set of possible outcomes of an experiment is called sample space of the experiment. So suppose I take an example, rolling a coin. So if I flip a coin, we'll get two sample spaces. That is head or tail. It means while we are flipping a coin, either we will get an head or we will get an tail. So those are the possible outcomes of the experiment. So those head and tails are called possible outcomes of the flipping a coin. So it is called sample space of an experiment. So likewise, we can able to discuss many examples and we can able to generate many possible outcomes for the given experiment. So this is the sample space on a space of an experiment. So likewise, in rolling a dice also, we are having six faces and six numbers in a die. So whenever we throw a die, we'll get some set of all possible outcomes like 1, 2, 3, 4, 5, and 6 because there are six faces in a die. So for every for every experience, we will get different output. Like for first time we will get one, or second time we will get six, or third time we will get four. Like that, we will get different types of outcomes. So that's why 1, 2, 3, 4, 5, 6 are the possible outcomes for rolling a die. And coming to flipping a coin, head and tail are the possible outcomes for the flipping of a coin. So this is called sample space. So what do you mean by sample space? Means it is set of possible outcomes of an experiment. So this is the definition of the sample space. Now we will discuss what do you mean by event also. And also, how we will denote this sample space means we will denote this sample space by S, capital S. So, capital S is the sample space which we will denote in probability. And also, this kind of experiment is called a random experiment. And also, whatever we are conducting this experiment is also called as random experiment. Why we are calling this experiment as random experiment is we are experimenting, we are conducting this, we are conducting an experiment, doing, considering an experiment randomly. It means we are randomly doing experiment for that, for that purpose. That's why it is called random experiment. It means we are experimenting randomly. That's why it is called random experiment. So we will see those things in further. So what do you mean by event? So will tell a generalized example. After discussing generalized example, we will come to know what do you mean by event. So suppose I have thrown a dice. So after throwing a dice, I have got six possible outcomes: one, two, three, four, five, six. So now I am asking, what is the probability of getting even numbers in throwing a single dice? So whenever we throw a dice, I am asking what is the probability of getting even number? So after throwing a dice, from that all possible outcomes, what are the possibilities of getting even number from that sample, from the set of possible outcomes? Suppose we got 1, 2, 3, 4, 5, 6 as a possible outcomes in random experiment. From that all possible outcomes, I am asking what are the possibilities of getting even number from that possible outcomes. So from 1 to 6, we are having only three even numbers. That is 2, 4, and 6 are the even numbers possible to get in throwing a die. So getting an even number, getting an even number from the set of all possible outcomes is called an event. It means we are extracting some possible, we are extracting some events from the set of all possible outcomes. It is called an event. An event is nothing but the subset of possible outcomes. It means from the possible outcomes we are taking some outputs and we are extracting it. So that is called an event. So we'll see what do you mean by event through the definition. Any subset of E of the sample space is known as an event. So what do you mean by event? Means subset of the sample space is called an event. So subset is E. So what is the relation between the E and subset and set? Means E is a E is a subset of S. It means it is nothing but part of the elements that are containing in E. Definitely they will be present in the S. That's why it is a subset. E is a subset of S. So that is the subset of the sample space. It means whatever the event that we are getting, those events are already present in the sample space. That's why it is called a subset of the sample space. So this is called an event. So an event is set consisting of possible outcomes of an experiment. So what do you mean by event? Means it is like a set which contains possible outcomes of an experiment. It means whatever the possible outcomes that are possible, it will contain those possible outcomes from that experiment. So I mean, an event is nothing but we are taking some taking some sets from the from the set of possible outcomes. So it is nothing but subset. So subset of the sample space is called an event. So that is what we are discussed. So we will see now. And also, if the outcome of the experiment is contained in E, then we say that event A has occurred or event E was a success, otherwise it is a failure. Suppose we experiment through flip of the coin or rolling a dice. Suppose that outcome of the experiment is containing in E. It means nothing but whatever the outcome that is present in the experiment, suppose that is contained in E. It means that is contained in the event E. Then what do you say that? Then we will say that an event has occurred. It means whenever the outcome is contained in E, at that time we can able to say that the event E has already occurred or event was a success. Because why event was a success means we got already we contain the outcome of the experiment in the event. So whenever the event contains the outcome of the experiment, then we will say that an event has occurred or an event was a success. Suppose if it is not contained in the E, then we will say it is a failure. So We'll see some generalized example. So two children in a house. So if I take, suppose if I take two children in a house. So we so now I am taking the example of this. Uh, with this example, we will come to know what do you mean by sample space and what do you mean by event. So suppose I am taking two children in a house. Suppose there is a house. From that I am asking two children. So here I am conducting random experiment. So what is the random experiment means? Gender of the two children. It means we have to know what is the gender of the two children. It means whether the two children are male or female. It means that is the random experiment. What is the random experiment of this example? Gender of the two children. It means we have to know what is the gender of the two children, whether they belongs to male category or whether they belongs to female category. So we will see sample space. So I already discussed what do you mean by sample space means set of all possible outcomes in an experiment. Now we'll see what is the set of possible outcomes. So these are the possible outcomes. Suppose there are two children. Suppose I am considering first children is male and second children is also male. That is one sample or possible outcome. Next first children is male and the second children is female. Next one, first one is female, second one is male. Next one, both are female. So these are the possible outcomes from the random experiment. It means they may contain two male children, or they may contain they may contain one male and one female, or they will contain one female and male, or they will contain both of them are two female children only. So now I am taking event E. What do you mean by event means subset of the sample space. So what is the event of getting one boy and one girl from the sample space? So we are having only two possibilities for getting one boy and one boy and one girl. So that is male and female, or male and female and female. So this is the possibility of getting one boy and one girl. The event is from the sample space. So look here, this this event is the subset of sample space because this MS and FM are the already they are present in the sample space. That's why it is the subset of sample space. So this is the meaning of this is the definition of sample space and event. So what do you mean by sample space? Means set of all possible outcomes. So what are the experiment that you are conducting? From that, what are the probable outcomes that you get? Those are the sample space. From that sample space, what are the event that you are taking based on that condition? That is an event. It means event is nothing but the subset. It means from that sample we are taking some events. So that is one. So this is the example. So next example is two dice are rolled. Suppose I have taken two dice and rolled. So here we will see what do you mean by random experiment. So what is the random experiment of this means? See the numbers on the dice. So whenever I throw two dice, I have to see the numbers on the two dice. So one or one two or two or three are like that. So those are the numbers on the dice. So this is the random experiment. Now we will see what do you mean, what is the sample space. Sample space means um, set of all possible outcomes. So what are the possible outcomes when we throw two dice? So one, 1, 2, and so on, 1, 6, 2, 1, 2, 2, 2, 3, and so on, 2, 6, like that up to 6, 6. So these are the possible outcomes when I throw a two dice. So this is called sample space. Next, event T. So what here I am taking an event, sum is prime. So suppose if I add two numbers, that should be a prime number. So what are the prime numbers? 2, 3, 5, 7, 11. So these are the prime numbers up to 12. So we will see what are the possible outcomes for this event. So 2, 3, 5, 7, 11 means 1, 1, 1, 2, 2, 1, 1, 4, 4, 1, 2, 3, 3, 2, 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1, 5, 6, 1. These are the possible outcomes for this event. Because if you do this sum, we'll get 2, 3, 5, 7, 11 only. So that's why this is the event of getting the sum is prime. So how many possible what are the number of possibilities getting this sum is prime means total 15 possibilities. That's why I'm taking the probability of getting 15 because we are getting 15 possibilities in order to get the prime number. So that is what. So these are the elements of the probability. So till now we discussed about the elements in the probability. Now we will go to the concept of probability and we will discuss what do you mean by the probability. So before going into the probability, we will discuss. Suppose there are some certain teams in the. Suppose I take an example as an IPL. Suppose if I take an example as an IPL, there are 10 teams. Suppose there are 10 teams. So after from the 10 teams, I am asking to what is the probability of what are the probabilities of the teams that which they enter into the semi-final. It means there are already 10 teams. From the 10 teams, I am asking what are the chance. It means from that, and I am taking four teams. From that four teams, I am asking what is the probability of getting selected to the semi-finals. It means I am asking what is the probability. It means what are the chances of getting those four teams into the semi-finals. It means we are finding. It means we are estimating. It means we are how much percentage that the team have to enter into the semi-finals. Suppose already suppose some of the matches were completed by the IPL 10 teams. So after completion of the matches, it means only few matches of the completion. I'm asking how many teams will definitely enter into the semi-finals. Already we know only four teams will enter into the semi-final. I'm asking what are those four teams by looking at the net run rate, by looking at the points, what are the possibilities like that. This is the probability. It means what is the probability means it is the measure of the likelihood of an event to occur. So measure of likelihood of an event to occur. It means we are measuring the event. It means what is the chance of a team getting a title in the final. This is the probability. It means we are measuring the winning chances. Suppose there are two teams. Those two teams are went into the final. In that final, I am predicting what is the probability of winning that team IPL title. So team A is there, team B is there. I am asking what is the probability of winning team A in the final. So we'll say some people will say 50%, some people will say 60%, and some people will prefer team B 70% like that. So like that, we will give some predictions and we will do some measures on the teams. So that is the probability. So probability is a measure of likelihood of an event to occur. It is nothing but a measure of likelihood of an event occur. So probability of event to happen is. So what is the formula for the probability of event to happen? So we will represent the event as E. So P of E equal to P of E indicates that probability of an event E to happen, that equal to favorable outcomes in A by total number of outcomes. It means what are the favorable outcomes that are present in A. Those are the favorable outcomes in A by total number of outcomes in S. It is nothing but mod of E by mod of S, because in probability we do not have negativity. That's why in order to negotiate that negativity, we'll take that mod. So generally we don't see negative values in the probability, but for the safer side, I am taking the modulus symbol. So mod E by mod S. So what is the mod E means favorable outcomes in event E. But what is the S means it is the total number of outcomes in sample space. It means number of favorable outcomes the total number of outcomes in sample space. So this is the formula for the probability of event E. So whenever if you want to find the probability of event E, you have to go through this formula. So whenever you go through this formula, you will get the required output. So now we will discuss some examples. What is the probability of getting the sum as a prime number when you are throwing a two die? Already we have seen this example. So whenever you throw a two die, what are the possibilities? It is what is the possible outcome? 1, 1, 1, 2, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and so on up to 6, 6. So these are the probable. These are the possible outcome. So now we have to take an event. So what is the event? Sum is prime. So if we had those two numbers, they should get prime number. So we'll go through above slide and we'll see. So here see, these are the events that we will get whenever we add those two numbers. We'll get the sum as a prime number. So how many events are there? 15. Out of 36, we are considering only 15 because by adding only those 15, we'll be getting this prime number, sum as a prime number. That's why we take E as E equal to 15. So probability of getting the sum as a prime number is 15 because those are the 15 favorable outcomes in order to get sum as a prime number when we throw a two die. So what are the total number of what are the total number of outcomes is 36 because from 1 1 to 6 6 there are 36 possible outcomes. So now I have to find the probability of getting the sum as a prime number means already we have discussed the formula. What is the formula? Number of favorable outcomes by total number of possible outcomes. What are the favorable outcomes? Favorable outcomes is nothing but sum is prime. So what is the sum is prime means E equal to 15. So the 15 number of favorable outcomes. So out of 36 we are getting 15. So that's why mod E by mod S. So mod E by mod S means number of favorable outcomes of 13 and total number of possible outcomes of 36. So probability of occurring event E equal to 15 by 36. That is 5 by 12. So that is the answer. Next one. There are 6 pillows in a bed. 3 are red, 2 are yellow, and one is blue. You pick a pillow. What is the probability that it is yellow? Here we are having 6 pillows in a bed. Suppose we are containing a bed. So in that bed we are containing 6 pillows. So from that 6 pillows, three pillows are red color, two pillows are yellow color, and one pillow is blue color. So they are asking, um, we pick a pillar. It means we have to pick a pillar. What is the probability that it is yellow? So they are asking what is the probability that you pick a pillar and that belongs to yellow color. So here we have to take the sample space. What is the sample space? 6 pillows. So we have to take 3 reds. So R1, R2, R3. Next one, 2 yellows. Y1, Y2. Next one blue. So B1. And total number of sample space, total number of possible outcomes are 6. That's why mod x equal to 6. Now they are asking what is the probability that that you pick is yellow. So Here I am here. The event that I am taking is the probability that I am taking a yellow. So here, how many yellow pillars are there? Two yellow pillars. So the probability of an event that I take yellow pillar is y1 and L2, y2. Only we are having two possibilities of picking yellow color. So that's why I am taking mod e equal to 2. So picking a yellow pillar. So picking a yellow pillar means now we are having only two possibilities, either y1 or y2. So that's why I am having total favorable of it means now I am sorry. So picking a yellow pillow means now I am having number of favorable outcomes equal to 2 because y1 and y2 are the only favorable outcomes. So now I am taking what is the probability of an event that I pick an yellow. So what is the probability formula? Number of favorable outcomes by total number of possible outcomes. Here what are the favorable outcomes of getting yellow means 2 by what are the total number of possible outcomes? 6. 2 by 6 equal to 1 by 3. So 1 by 3 is the probability of getting probability that I am picking that is yellow pillow. It means 0.33. So this is the probability of an event that I pick a yellow pillow. So this is the answer. Next one, union of events. So we'll see what do you mean by union of two events or more than two events. Suppose I am containing two events C and F and from the sample space. Suppose we are having some sample space S, which means total number of sample space depending with sample space S. And from the sample space I am having two events. So namely E and F. So E and F are the two events from the sample space. We define the new event G equal to E union F. So so I am defining this in union with the new variable called G equal to E union F. It means E union F is called so this E union F is called as the union of the events E and F. It means what do you say from that E union F means whether it consists of all the outcomes from either in A or either in F or in both E and F. It means what do you say about the E union F means it means all the outcomes it will consist of all outcomes that are either in E or either in F or in both E and F. It means all the possible outcomes may contain in either E or either in F or in both E and F. So suppose if I want to get some outputs, so those outputs will be containing in event E or event E map, or suppose that all the possible outcomes will contain in both E and F. So that is an example. Here see, here I am representing this E union F through Venn diagram. This is the E and this is the F. And this rectangular shape is the sample space. So from that sample space, we are taking two events, C and F. So this middle part is called an intersection part. So E union F means either E or either F or both either E and or both E and F. Both E and F means this intersection part. Either E or either F or this intersection part. This intersection part means both E and F. So this possible outcomes will contain. So all the possible outcomes may contain in E or either in F or in both the cases E will contain. So this is the E intersection F. So this is the Venn diagram that I am representing E intersection F. Now I will explain about the mutually exhaustive events. So what do you mean by mutually exhaustive event means? Suppose I am containing two events E and F. So uh, suppose I am containing two events E and F from the sample space. So whenever you do this union, those union of those two events must cover the sample space. If the union of those two events cover the sample space, that is called mutually exhaustive events. So whenever you do those two events, there should be union, those should be covering the sample space. It means what are the outputs that are what are the outcomes that are containing in the sample space. So whenever you do those two events E and F, those should be covered by this sample space. It means what are the possibilities that are containing in sample space. This union also must cover those samples outputs. That is called mutually exhaustive union. Yes, see that if E union F equal to S, then E and F are mutually exhaustive. It means their union is covering the entire sample space. It means whenever you do union of two waste events, whenever you do union of two events, they should cover the entire space. That is called mutually exhaustive events. Whenever those two events cover the entire sample space, then we will say those two events are mutually exhaustive events. So that is. So I am considering one example here. So here I am considering one random example. What is random experiment? So what is the random experiment is throwing a die and note the number on the top. So after suppose I throw a die and I am noting the number of the top. So whatever the number that I am getting on the top, I am noting the number. Now, from that random experiment, I am considering two events. What is the first event? Getting an even number. So, what is the probability of getting an even number for the event even? Next event 2. So, what is the probability of getting an odd number? E2. So, now we will see. Here, sample space. It means total number of possible outcomes are 1, 2, 3, 4, 5, and 6. So, even is the even, getting an even number. So how many even numbers are there from the sample space? Three even numbers. What are they? 2, 4, 6. So for even 2, 4, 6 are the possible outcomes of the 2, 4, 6. E2. So what is the E2? Getting an odd number. So getting an odd number from the sample space means what are the possible sample spaces? 1, 3, and 5. So those are the sample space. Now I am doing this union. So even union E2. It means whenever you do union, you have to combine all the elements that are present in both even and E2. Whenever I do combine, I'll get 1, 2, 3, 4, 5, and 6. So whether this union of these two events combine cover the total entire sample space or not, because the sample space containing 1, 2, 3, 4, 5, and 6. So this union of these two events also containing 1, 2, 3, 4, 5, and 6. So those are the union of these two events. So here we got the we covered the entire sample space. So this event is said to be mutually exhaustive because union of those two events covered all the total entire space. So that's why I said this event as a mutually exhaustive event. So here I see P of even probability of even intersection even union E2 equal to even union E2 by S. So what are the total number of possible outcomes that I got when I did even even union E2 means 6. So so we got six possible outcomes when I do union of these two events. So what are the possible number of outcomes? 6. So 6 by 6 equal to 1. So from this we can able to say even and E2 are mutually exhaustive because this union of these two events covered the entire sample space and we got the probability equal to 1. So these are mutually exhaustive. This is, I think, hope you understood. So we'll see the next example also. Random experiment is throwing a die and noting on the number. First event is getting a prime number. So what is the probability of getting a prime number? What are the probabilities? 2, 3, 5 are the prime numbers. So that is the event one. Next event, getting neither prime nor composite. It means we should not get either prime number nor a composite number. So only one, we are having only one possibility, that is one. Next one, getting an even number. So what are the even numbers means 2, 4, 6. So these are the three events which are covered. So what is the sample space means 1, 2, 3, 4, 5, and 6. So these are the total possibilities of an outcome. Now we will see, we will do the union, even union E2. So whenever I do even union E2, so what do the even contains 2, 3, 5? What does the E2 contains 5? So whenever I combine this, I'll get 1, 2, 3, 5. Next, whenever I combine even union E3, what I will get means 2, 3, 4, 5, and 6. But we did not cover all the events. Whenever I combine E2 union E3, I'll get 1, 2, 4, and 6. Now I am combining all the three events, even union E2, union E3. So whenever I combine all those three things, I am getting 1, 2, 3, 4, 5, and 6. So here, whenever I do union of all the three events, when I compare with the total sample space, it has covered all, both are equal. It means this union of these events covered the total entire sample space. So this covers the concept of mutually exhaustive. So from this, I can able to say this is mutually exhaustive event. Now I will say intersection of two events. So what do you mean by intersection of two events means? Suppose I am considering two events E and F from the sample space, and now I am creating a new event called G. G from the G I am calling E intersection F. So E intersection this is called the intersection of E and F. It means the all the outcomes should be covered by. It means all the outcomes should be in both E and F. In union, what we discussed means all the possible outcomes should be in either in E or either in F or either in both E and F. But coming to intersection part, it should contain in both E and F. It means it should cover both E and F events. So that is called intersection event. It is nothing but the common path. So E intersection F is nothing but the common elements that are present between the two events. And that is this is the event E intersection will occur if both events E and F occur. So what do you mean by E intersection is? So it will occur whenever both the events E and F occur. So whenever both the events E and F occur, this event E intersection will occur. So that is the meaning. So here take the sample space. Now take the two events E and F. So the E intersection F is the common part of the two events. So this is the common part which is taken between two events. So the common part is called the E intersection F. So intersection of those two elements is nothing but taking common elements between the two elements. Now we will say the formula. E intersection F equal to event E plus event F minus E intersection F. So from that we can able to get the common element. It means this is union, sorry. So E union F equal to probability of event happening E plus probability of event occurring F minus E intersection F. This is the formula for the E intersection F. It means probability of occurring either E or F equal to probability of occurring E plus probability of occurring F minus probability of occurring both event E and F. So whenever you do the subtraction, you will get the intersection F. So intersection of two events means taking common elements from the two events. So that is. Now we see mutually exclusive events. So what do you mean by mutually exclusive events? Suppose if I take two events E1 and E2 or E and F. So whenever I do intersection, suppose there are no common elements between the two events, then it is mutually exclusive event. It is nothing but there are no common elements between those two elements. It means what do these mutually exclusive events will say means E and F cannot occur simultaneously. It means E and F cannot both occur. E and F are said to be mutually exclusive. So when do you say E and F are said to be mutually exclusive? Whenever both the events E and F cannot occur both. Whenever E and F both cannot occur, then we can able to say mutually exclusive events. Or we can able to say when there are whenever there are between E and F, these are called mutually exclusive events. Here, see the example here in the diagram. This rectangle shape is the sample space. From the sample space, I am taking two events E and F. So these two events are mutually exclusive events because no elements are present, no elements are common in between these two elements. So we can also say that these two events are independent to each other. So whenever you do this intersection, we'll get zero or we can get empty set. So there are no common elements between two events. So like that you can able to see. So A intersection F equal to pi. So modulus of A intersection F equal to 0. So the probability of getting both the events is 0 because they are independent to each other and also there are no common elements. So that's why we are getting 0. So this is one. Next, next we will discuss with an example. So now we will discuss some examples. So here we are taking some example, random experiment. So what is the random experiment? Throwing a die and noting the number on the top. So same like the previous example, this is the random experiment. Now I have to take two events. So what is the first event? Getting an even number. What is the second event? Getting an odd number. So now we have to take some sample space. So whenever I throw a die, what are the possible outcomes? 1, 2, 3, 4, 5, and 6. So this is the sample space. So in this sample space, we store the all the possible outcomes 1 to 6. So what is the probability of getting an even number? So in from the six possible outcomes, what are the probability of getting even number? 2, 4, and 6. These are the events. These are the even numbers that we get when we throw a die. So even contain 2, 4, 6. Next one, getting an odd number. What is the probability of getting an odd number? So what are the possibilities of getting odd number? Means 1, 3, and 5 are the possibility of getting an odd number. So 1, 3, 5. Even 2 will contain the elements 1, 3, 5. So now I will take even intersection E2. So whenever I take these two events and whenever I try to take common elements, so from this even in E2, there are no common elements. It means they are odd numbers, these are even numbers. It means those two sets are independent of each other because set 1 containing even number, set 2 containing odd number. So there are no common elements. It means we are getting empty set. So whenever we get an empty set and whenever there are no common elements, then we say that they are mutually exclusive events. It means here even and E2 are the mutually exclusive events because of no common elements between the even and E2 events. So that is. Now I am taking the same example. First event is getting a prime number. Second event is getting neither prime nor composite number. Now E3 is the event that is getting an even number. Now I will take sample space. So whenever we throw a die, we will get the total number of possible events in the sample spaces 1 to 6. And from the first event, what is they are asking? They are asking prime number. So what are the prime numbers that are present in the sample space? 2, 3, 5. So event containing 2, 3, 5 are the prime numbers. So what is the E2 getting neither prime or composite? So only one is the possibility of getting neither prime or composite number. Next one. What is the probability of getting an even number means only 2 and 4 and 6 are the only possibilities of getting an even number from the sample space. So E3 will contain 2, 4, and 6 elements. Now I will take Now I will check whether even E2, E3, E2, E3 and even E3 are mutually exclusive or not. Now I will check even and E2. So whenever I do intersection of these two, even and E2, there are no common elements between the event even and E2. So they are containing the empty set. So even and E2 are mutually exclusive. Now I will check Now I will check even intersection E2. It means um, we are we are trying to take a common element between the getting a prime number event and getting an even number event. So what are the 2, 4, 6 is the even number, and yeah, okay, wait, even intersection E2 getting a prime number is 2, 3, 5. Next one, what is the even getting neither prime or nor composite is getting a. So what is the even intersection E2 means? There is no common part. So there is no common part. That's why we can able to say even an intersection E2 is equal to pi. So even and E2 are mutually exclusive. Now we will discuss E2 intersection E3. It means we are able to take the common elements between the E2 event and E3 event. What does the E2 event contains? 1. So what does the E3 event will contain? 2, 4, 6. Whenever I do intersection of these two elements, there are no common elements and we are getting the empty set. So yeah, here also I am getting empty set. So E2 and even and E2 are mutually exclusive, and likewise E2 and E3 are also set mutually exclusive events because of no common elements. Now I am taking E1 and E2 and E3. So whenever I take intersection of these three, even intersection E2 intersection E3, there are no common elements because there are common elements between E1 and E3, but there are no common elements between E1, E2, and E3. That's why they are, but there is a common element between E1 and E3. So that's why these E1, E2, E3 are mutually exclusive, not mutually exclusive. So if E1, E2, E3 wants to be mutually exclusive, all the events should be in mutually exclusive manner because E1 E2 are the mutually exclusive event, E2 and E3 are the mutually exclusive. But whereas coming to E1 and E3, they are no mutually exclusive because there is a common part. What is the common part? 2 is the common part. So here the condition is not satisfied. In order to all the conditions should be satisfied in order to say E1, E2, E3 are mutually exclusive. But here the condition is failed. So we can able to say E1, E2, E3 are mutually exclusive. That is. Now we will discuss some properties. NN and intersections are commutative. It means NN of events and intersection of events are commutative. It means E intersection E union equal to F intersection F union E. These both are same because whenever you combine this E and F or whenever you combine F and E, we will get the same output. So that's why they are commutative. Next, E intersection F equal to F intersection E. So these are also commutative because from the both events we are taking only common elements. So even if you take E intersection F or F intersection E, we'll try to get only common elements between the two elements. That's why they are commutative, and they are associative also. How means E union F in union G equal to E union F or F union G. So here also we are combining all these three inverse. So if you do in this way, you can also get all the combination of these three elements. Or if you go through this way, yeah, you can also get all the combination of these three elements. So this is what it is saying. So in union is also associative because by doing these two methods, we will get all the total possible outcomes in the sample space. Like that intersection also, E intersection, F intersection G. So here first one they will take the common part between the F and G. After that they will they will apply intersection on that part. So from that they will take the common part. Here also they will take the common part from the E and F. After that we are doing intersection on G. From that we are taking the common part. So here entirely we are taking common part from all the three elements. Okay. So these both two events are doing same operation. So these are associative also. Next one, union and intersection are distributive. That means E union F intersection G equal to E union F intersection E union G. So like that you can be able to represent this formula as this. So you can also see E intersection F union G. How can you able to see E intersection F union E intersection G? So we can also say union and intersection are distributive. See, see here I will represent in the I will show in the Venn diagram. So these are the Venn diagrams. So see here, this is an example of E union F and these are the examples. Go through these diagrams. Now I would like to discuss complement of an event. So what do you mean by complement? So what do you mean by complement of an event? Suppose we are containing an event. Suppose I am taking one sample space. From that sample space, I am considering an event. So how do we define that event A? So suppose the event of the all the outcomes are present in the sample space, then we will say that it is an event. So what is the complement of an event means? Just it is opposite of the definition. So the all the outcomes in the sample space which are not in V. So what is the difference? What is the relationship between the sample space and event means? These are the subset. E is the subset of sample space. So what is the complement of event means? E is not subset of sample space. It means what are the things that are present in event E, those are not present in the sample space. That is the complement. So this this definition also saying like that only. See, for any event E, we define the event E complement or E, E bar or E complementary. So if we want to define if we want to represent the complement of an object, we can able to represent in E bar or E complement, referred to as the complement of E. So we can also able to refer to the complement of E to consist of all outcomes in the sample space. Yes. So all outcomes in the sample spaces which are not in E. So what are the sample space that which are what are the events that are containing the sample space? Those will not be present in this event. So that is the complement of E. So here see the example. This is the sample space. So this is the event E. So this circle is the event E. So what is the event bar means? E complement is what are the outcomes that are not present in the E? It means this entire space. So what are the red color that I am showing? This is the complement of an event E. We can represent it as E bar because those are the elements that are not present in the event E. So that's why that is called E complement. How do we represent this? What is the formula of E complement means? We are subtracting the sample space from the event. So if we subtract sample space from the event, that is after that, what are the remaining part that is containing? That is the complement of the event. So we'll also represent P of E bar equal to 1 minus P of E. So probability of getting E complementary equal to 1 minus probability of getting E. So whenever you do subtraction with 1 minus P of E, you will get the remaining part. It means complementary part we can able to get. De Morgan's law. What do you mean by De Morgan's law? We'll see. E union F whole complementary equal to E complementary intersection F complementary. It means next, what is the formula for E intersection F whole complementary means E complementary. So for the complement of intersection, what is the complement of intersection? Union. That's why I am taking union. Intersection union F bar. That are those are the De Morgan's law. Those are the properties of De Morgan's law. Here see the E union. This is the pictorial representation of A union F whole complement. So this is the whole complement. This is the pictorial representation. A union F whole complementary means accept the E union F means this is E union F whole complementary means out of this sample space. So this is the shaded part. This is the E union F whole complementary. Next one. E intersection E complementary intersection F. So this is the E intersection E complementary intersection F complementary. Next, subset of an event. So when now we will discuss about the subset of an event. Suppose if I take two events E and F. So if I all the outcomes in A are also in F, then we can able to say E is a subset of F. Suppose if I am taking two events E and F, so what are the outcomes that are present in the E? So those outcomes are present in F also. We'll say that E is a subset of F. It means whatever the elements that are present in the E, those elements are present in the E, then we can able to say E is a subset of F. So we can represent it like this one. E is subset of F. Or we can also use this F is a superset of E. And next point see, if E is subset of F and F is subset of E, then we say that F and E and F are identical. So when do we say E and F are identical? It means when do we say both E and F are identical? Means whatever the elements that are containing in the, so the elements that are present in both E and F should be same. So whatever the elements that are containing in the same elements should be present in the F. It means they should contain equal number of elements and they should contain the same number of elements. Then only we can be able to say they are equal. At that time we can able to say E equal to F. See here, this first one is the first circle is the E and next circle is the F. So E is the subset of F because whatever the elements that are containing in E, those elements are already present in the F. So that's why it is the E is the present E is the subset of F. From this diagram we can able to say E is subset of F, F is subset of E, and E equal to F because both are containing the equal number of elements and both are containing the same number of elements. So whenever the first two elements containing the same number of elements and equal number of elements, then we can able to say that, then we can able to say they are the subsets of an event. It means they are identical to each other. Next one, axioms of probability. So what are the axioms of probability? First axiom is the probability of the event will lie between the 0 and 1 because if you take any number of probabilities, if you take any number of events, you will get the whenever you count that, you will get the values between 0 and 1 only. So the problem that event probability will lie between the 0 and 1 only. So that is what the axiom 1 is saying. Next axiom 2. Probability of x equal to 1. It means the total number of sample space is equal to 1. So suppose if we are taking an event, suppose we are getting an sample outputs. So whenever you add those, we will get the total probability as 1. It means the total probability should be equal to 1. So that is certain event. That is called certain event. So next axiom. For any sequence of mutually exclusive events, even native and zero, they should contain P of even intersection, union, native, so on. Then we can able to say P of even plus P of E2 and plus P of En. This is the axiom E3. Next one, we see what is the axiom of even union, E2 union, E3 union, E4 equal to E1 plus E2 plus E3 plus E4. It means the probability of occurring even intersection union E2 intersection E3 union E4 equal to P1 of probability of E1 plus probability of E2 plus probability of E3 plus probability of E4. They will not take even intersection E2 because they are independent of each other. So whenever the events are independent of each other, they are equal to zero. That's why I have written P of E1 plus P of E2 plus P of E3 plus P of E4. Next one. Suppose I am taking one example here. A total of 30% American men smoke cigarette. It means in American 30% male will take cigarette, smoke cigarettes. So some 10% people will smoke cigars and 5% will take both cigars and cigarettes. So what percentage of most will smoke neither cigarette nor cigarette? It means they are asking about the what is the P of E. It means they are asking what is the probability of A union B whole complement. So first of all, we will take the events one by one. So what is the probability of A means cigarette. So probability of A equal to 30% means 0.3. What is the probability of B that will take that the people will prefer cigarettes means 10%, 0.1. And now we will see what is the probability of A intersection B. A intersection B means both cigarettes and cigars. The people who will take both cigarettes and cigars are 0.05. Already they have given. Now what I will tell is I will take intersection union. What is the probability of A union B means P of A plus P of B minus P of A intersection B. It means 0.3 plus 0.1 minus 0.05 equal to 0.35. Now what they are asking is P of A union B whole complementary. It means they are asking complementary. So what is the complementary part? 1 minus what is the complementary P of A union B whole complementary? We have to just subtract from 1. 1 minus P of A union B. It means you have to subtract this 0.35 from 1. So 1 minus 0.35 equal to 0.65. So this is the percentage of more means who will not smoke in either cigarette or cigars. So I think hope everyone understood this example. Next one. So this odds in favor and odds in against are the events. So what is the meaning of odds in favor? Means odds in favor of a particular events are given by number of favorable outcomes to the number of unfavorable outcomes. It means it will depend the formula. It is number of favorable outcomes by number of not favorable outcomes. It means P of A by P of A whole complement. So we'll take this formula. So we no need to learn more about this. Just we have to remember the formula. So odds in favor of an event A means probability of an event A by probability of A complement. It means P of A by 1 minus P of A. So that is the odds in favor. Odds in against means just reverse to it. It means odds in against is given by the number of unfavorable outcomes to the number of favorable outcomes. It means P of A bar P of A P of A bar by P of A. So favorable outcomes means P of A by P of A bar. For unfavorable for odds in favor means P of A by P of A bar. But odds in against means number of unfavorable outcomes to number of favorable outcomes. It means P of A bar by P of A bar. So this is one.